Hello everyone, welcome to Geoscience In this video, we are going to discuss about the NISAR data products. This is a collaboration of ISRO and NASA, and we are going to discuss about the different kinds of data products and their scientific applications. So, this course is actually designed for the researchers, postgraduate students, and other people who are also into disaster management, geology, hydrology, agriculture, forestry, and earth sciences. So now we are just going for a brief introduction, and then we'll go for more deep details in the coming videos. So first of all, we will just understand the scientific objective. So the objective of this lecture is to understand how are the NISAR products organized and what information do we get from these products and which scientific applications are we are going to use for that one. Okay, so first, when I'm opening two websites, one is Bhoonidhi and the other is ASF Datasearch. Okay, so I'll tell you why I have used these two. Before that, I just wanted to show you a particular area. So I'll just select here in the northeastern, and then I select a time range, example 1st of July to 5th of August, that is today. And then when we go for the satellite, you can just go for the NISAR. And when you go for the NISAR, you will see the products. See here, you are seeing level 1 RIFG, level 1 ROFF, like that level 1, level 2 GCOV, and then level 2 GSLC. So these are the products what you can get from Bhoonidhi website. So you can just go to the open data, and then you can see all these RIFG, ROFF, RSLC, and all those things. But when you go to this ASF data search, and then if you select same particular area again, say we go for the northeastern part again, and then when you select this part, and then if you give a date, see I've selected the NISAR here, and then I went for the search. Here I can see some more images like RRSD, which you don't see here, and then SME2, which you don't see here. So both the websites are giving you the data. So whatever is your application, you can download those data sets. Now we will go for each and every data product. Level 0. This is level 0, L0. Level 0 products. They contains the radar telemetry that is recorded by the satellite. These data sets include original radar echoes, timing information, satellite navigation data, and also the engineering measurements. So this doesn't have any major applications in the AdSense, but these are very much important. Then we go for the level 1 products here. Okay, so if you go for the level 1 products, in the Bhoonidhi also you can see the level 1 RIFG, ROFF. So if you go to that products, you can understand level 1 products are the first stage. That means at this stage, the radar observation becomes scientifically useful. At this level, the raw echoes have been processed into focused radar images. See, you can just have a look at this. See, so these are some level 1 products. Among these, we have different types. One is RSLC, which is radar single look complex. Just like in Sentinel, we used to have that SLC. The same way, we have RSLC. This radar single look complex, it is perhaps the most important product for the researchers that are generally working on the interferometric SAR. So, what is this RSLC image? This RSLC image contains both the radar amplitude and the radar phase. So the distinction is extremely important because amplitude describes the strength of the return radar signal, and phase will record the relative travel distance between the satellite and the Earth surface. Without phase information, and interferometric processing is impossible because this RSLC here, you see here, even here also, this RSLC preserves the complex valued measurements it forms from the starting point of the application. So this is mostly used in the earthquake deformation, ground subsidence, land subsidence monitoring, or landslide monitoring. And then if you take volcanic inflation and deflation, and also the infrastructure deformations. And you can also use this data for long-term series analysis also. So if your objective is to perform any of the interferometric processing, then RSLC is the preferred product. Then we are going to discuss about the next product, GSLC. Here also, if you can see, you have that GSLC, that is geocoded single look complex. Okay, so in this GSLC contains the same complex radar information as RSLC, but it has already been geocoded into a particular geographic coordinate system. So this will simplify the visualization, and it also helps in the integration of the data to the GIS software, any GIS software if you are using. Now I'll just show you one comparison. If you look at this RSLC, see the image which you are seeing here is somewhat like this. When you go for the GSLC, it is more assigned to the coordinate system. That means it is already geocoded into the geographic coordinate system. So the researchers who are working on with machine learning or image analysis or any kind of geographical information system will find GSLC to be more useful than RSLC. But depending on the processing workflow, some interferometric software packages may still require the RSLC as input. And then we are going for the next product, GCOV. So if you see here, you have the GCOV here. So GCOV means geocoded covariance. The difference is, unlike the RSLC, which emphasizes the phase preservation, but when it comes to the GCOV, it emphasizes the calibrated radar scattering behavior. See, these products are especially valuable for studies that are involving land surface characterization. That means forest biomass estimation and agriculture, wetland mapping, vegetation monitoring, land cover classification, snow and ice studies, coastal environments, and also oil spill detections. So GCOV products are particularly important in polarimetric radar analysis because they preserve the information about the scattering mechanism of different surface materials. Okay. And then next, there are some more products. They are GUNW. So you can see here, yes, GUNW. This is geocoded unwrapped interferogram. See, can you see this fringes? So this product contains an interferogram that has already undergone the phase unwrapping. Initially, what you are doing, you are downloading the SLC, and then you are doing the split, and then applying orbit, and then going for back geocoding, and then going for the interferogram formation, phase wrapping, unwrapping, export, and everything. Instead of producing an interferogram by yourself, NISAR provides a scientifically produced displacement product. That is the easiest and most helpful thing. So this information includes the line of sight displacement. It, you can see here, you have line of sight displacement, and then you have the coherence, you have the unwrapped phase, and then you have geometric correction. And these are particularly useful for earthquake studies, landslides, subsidences, volcanoes, and infrastructure monitoring. So people who are going for this deformation studies, they can use this product. And then we go for the next product, GOFF. See, it's here. I think you can clearly see the image, GOFF. So this GOFF is geocoded offset field. It's not every surface moves slowly because large earthquakes, rapid glaciers, and some fast moving landslides or sea ice. These phenomena are exceeding the limits of conventional interferometry. That means when you go for a subsidence, when you are measuring a subsidence, it is a very slow process, so you can observe the trends. But when you go for a landslide, it's not a smaller thing. It occurs very fast. So with this GOFF, instead of measuring the phase difference, GOFF will estimate the displacement by tracking the image offsets. So these applications include glacier velocity, larger co-seismic displacement, fast moving landslides, sea ice drift, even river ice movements also. So whenever interferometric coherence is lost because movement is too large, offset tracking will become more useful by using these images. So these are the 1 and 2. Now we are going for the 3. Here, level 3 products are representing the higher level science products derived from earlier processing stages. That means, depending on the mission release, they may include products such as surface deformation, um, mosaic or forest biomass, soil moisture, change detection, and also the regional monitoring datasets. For example, I will take this SME2. So we'll uh, understand this clearly when we are going for deeper investigations. So these are used for the surface deformation mosaic, forest biomass, soil moisture, change detection. So these products are intended primarily for users who require analysis ready information rather than raw radar measurements. So you can download these data either from the ASF or from this Bhoonidhi website. And then in the next videos, we will discuss more, and we'll also go for few more things like we'll just um, discover how to download the data and how to do the evaluation in the next video. So please do subscribe to Geoscience Engineering and follow the series for more interesting updates and videos. Thank you for watching.